Okay, good morning, everybody, and welcome back to day 2 of the Energy Data Analytics Symposium. So, first of all, yesterday we explored really 3 key topics in this space, and certainly want to reiterate our thanks to all of the speakers and moderators from yesterday's discussions. We talked about electricity grids and AI and the connections between those two and challenges and opportunities there. We talked about ethics and social responsibility of data analytics and some of the challenges that occur in this space, what we need to conceive of to see how these tools interact with the social good, how these tools interact with law, and what standards we need to put in place when thinking about these types of pieces. We talked about energy access in AI and how those types of tools are impacting sustainable development. Now, today, you may be a little bit surprised to hear that we're actually continuing the dive into many of these topics, but through the lens of remote sensing technologies. So we'll make those connections a bit more clear in just a minute through a bit of a forward-looking recap, a free cap, if you will. So first of all, what are remote sensing technologies? So when you think about satellites, aerial imagery from airplanes and other sorts of piloted craft, drones, all of these are tools to help us acquire information about the world, earth sensing technologies. And the data science tools help us to understand and gather insights from these data more rapidly and globally than ever before. So as we start to think through this, some of you may have seen this outside at the check-in booth. This is an aerial image. For those of you who are interested, it happens to be Groton, Connecticut. And it has a few very interesting things that are present within this. Now, at first blush, you must just say, well, that looks like a typical Google Earth image to me, right? But if you look carefully, there are a number of interesting things over here. So first of all, what do we got going on over here? We've got a solar farm, very clearly visible in here. Now, if you zoom in this central community here, what you can actually see is almost every rooftop has solar PV. If you couldn't see the solar PV because they were covered by trees, somebody installed it wrong. So you can continue looking. There are many other insights that are possible here. If you look over on this side, what do we see? What is this giant streak here? Well, that's a transmission right-of-way, right? And actually, you can see it transition here from the transmission to distribution lines right there. And at that intersection point, at that node in between, we have a substation right there in visible. Now, there are other things that we can learn from here beyond this about energy systems as well. We could potentially even see traffic patterns. We'll actually hear some folks looking into transportation later today. So all of these different types of insights, there's a lot that we can learn from these technologies if we're able to analyze these types of data at scale and to do that in a way that derives valuable information to stakeholders in the space. So what I want to do is to briefly introduce 4 common energy application areas that many of the speakers will touch on throughout the day today, and just introduce how we might think about these from a remote sensing point of view. Okay? So primary energy resources, generation infrastructure, transmission infrastructure, and electricity consumption and access. We can learn about each of these through remote sensing technologies. So first of all, and this is actually the figures in here from a paper that we had co-authored, a review paper with both WRI and NREL. So this actually is talking about existing applications across many different research groups and folks in the space. So so one example here, we have primary energy resources, solar energy generation, estimation, and forecasting. We can improve by using certain types of remotely sensed data, information about how much solar insolation is actually hitting the Earth's surface, weather patterns to make sure what is actually connecting, to predict and increase our ability to accurately forecast solar, and things like wind, and potentially even hydroelectric power and geothermal using different types of remote sensing data. Now, this connects very much to Dalia Patino-Echeverry's work that she was talking about yesterday, and talking about the importance through the GRACE project that she's working on of uncertainty estimation for efficient operation in the presence of increasing renewable penetration. This is information that could be used as an input into that type of work, and that was one example of how this work connects. This is actually an example here showing a coal mine, and you can see the change that occurred from 2017 to 2021. You can actually visibly see the difference in the mining activities that were completed there. And we can even learn about the oil and gas sector in this case, identifying oil wells, looking at refineries, seeing tankers move around, storage tanks. There has been actually quite a bit of work looking at the roof on storage tanks actually will move up and down depending on how much oil is present. And so if you measure the shadow, you can see how much oil has gone in or come out of that tank. So there's a company, Orbital Insights, that innovated quite a bit in that space there. Now, yesterday we also heard from Joe DeCarolis, and what he was talking about there was quite a bit of information that the EIA does on energy generation infrastructure. What we have, what information do we have about it? We can learn also about energy generation infrastructure from satellite imagery. You can see from small-scale solar panels to large-scale power plants, we can see a lot in these types of data. And Johannes Friedrich from WRI had talked about how WRI collected the global power plant data set, again, in part using some of the information that can be present from here. The other piece that comes into play here is looking at risk monitoring and risk assessment, inspecting wind turbines for any blade damage that's done there, inspecting dams for surface cracks, potentially using drones. We heard from Sean Lackey from Duke Energy using thermal cameras on drones to inspect solar panels to see whether or not they were able to detect potential failures in those systems. Okay, so we also can learn about transmission and distribution infrastructure. Obviously, transmission infrastructure is more visible in these types of images. Distribution infrastructure tends to require far more high-resolution information to see anything about it because of the relative size of it. But Anders Peterson from World Bank talked about how he and his team were developing techniques to automatically identify transmission infrastructure globally, especially in the context of areas that are transitioning to electricity access. But in addition to actually finding the infrastructure, we also talked about how you can monitor the transmission line corridors for vegetation encroachment and high voltage insulators to make sure that they're still in working condition. And Jeremy Renshaw from EPRI discussed how these types of efforts were being advanced through data that EPRI was producing and through research that that organization and collaborators were working on in that space. Then, of course, we can even learn about electricity consumption and access using information about the size and shapes of buildings and properties of buildings that are visible in satellite imagery and remote sensing technologies. We can actually potentially get estimates of how much energy those buildings consume. That's a project our team is actually actively working on in collaboration with some of the Climate Trace folks, some of which you'll hear from today. And there's also a lot that we can learn about electricity access and reliability. Brian Min talked about his groundbreaking work using lights at night data to examine questions of electricity access globally using these types of techniques. And Kate Ivana from Millennium Development Corporation discussed the importance of gathering that type of data for informing system planning, performance monitoring, and the operation of systems in that space. Okay? Now, all of this, there's a lot of potential, and you're going to hear throughout today's sessions about the potential for these types of tools in this space. Far more interesting things even than I'm putting up here today. But one of the things to keep in mind that there are both challenges and opportunities in this space. And I think it's important to recognize and touch on some of those. So first of all, there's always this question of model accuracy and trustworthiness. You know, are the results that you can get, is the information that you can get from these techniques adequate to meet particular stakeholder needs? Does it have to be perfect? Can there be a margin of error? What is that? That needs to be factored in when thinking about these types of technologies. There's also, on the research side of these things, there tends to be a bit of a challenge of replication in this. That oftentimes, and again, this was the result of looking at hundreds of studies of these types of applications, but you know, almost half the studies didn't share data. Very few studies shared code for all the types of applications we were just talking about there, with some important exceptions, of course. But the lack of data, the lack of code, the lack of benchmark data sets makes it hard to tell who's doing what well and to catalyze further innovation in this space. So this is certainly an opportunity for all of us in the community to do better going forward, for sure. And there's certainly some key application gaps. You know, there's been a lot of work on you know, energy resources, power system infrastructure, but there are still gaps that remain in this space, and limited studies in Africa and South America and in the Oceania region. And so all of these are opportunities for all of us here today to think about how those gaps could potentially be filled. Now, I tend to be a machine learning guy too, and so I think a lot about the machine learning challenges in this space. And there are a few key ones that are preventing these techniques from being used at scale. One of those is domain adaptation. What I mean by domain adaptation, satellite imagery and aerial photography often brings up a lot of heterogeneity that exists across locations. The differences in buildings from Vienna to Khartoum to Bloomington, the buildings look different, the vegetation looks different, the conditions of the imagery that was gathered, whether there's some atmospheric differences at the time of data collection, all of these differences make it challenging to be able to apply universally techniques that were developed maybe with limited data from one or two locations, right? So these are ongoing challenges in that space, and gathering that labeled data may be very expensive to do as well. The other piece that can be quite challenging in this space can actually be the data collection itself. Getting data from satellite aerial imagery and UAVs or drones, these can be very expensive data collections. And oftentimes, to see the stuff we care about, we need very high resolution data, okay? And so when you look at the resolution that you need to see certain types of infrastructure, it becomes clear that you typically need to be in the range of, for many types of energy systems, of some very high expensive proprietary data, right? So how do we get access to that as a wider community without blowing the budget, right? So it's a relevant question that we need to discuss here, okay? So the last piece to mention here is around security, privacy, and ethical considerations. You know, there are challenges. A lot of the infrastructure that we're looking at in the energy space may be focused on stuff that is of national importance, right? How do we you know, balance the desire for innovation and for advancement in the technologies that are being used, while making sure that the infrastructure remains safe and risks are mitigated. It's an open question. Privacy is another issue in this space. From UAVs, which can potentially, for example, drones, where you can see potentially individuals going about their business, right? How do we engage with that type of information as a community responsibly? And the ethics, questions around environmental equity and the impact of energy systems on vulnerable populations. How do we factor that into the research that we're doing as well? Now, this very much connects to two of our panelists from yesterday as well. Lee Tiedrich had discussed the importance of standards for responsible use of tools that are developed through a multi-stakeholder process. And Ben Rashanak had emphasized the importance of factoring in environmental justice, considering social vulnerability and prioritizing interpretability and explainability of the AI tools that are brought to bear here. So hopefully, as this gives you a sense of some of the challenges and opportunities in this space, but really lays the groundwork for the discussions we're about to have. And so we're going to have two panels today, both focused on the opportunities of remote sensing for energy and climate data. The first focusing a little bit more on the potential for transformative impact. What are some of the awesome applications that are happening today and that demonstrate some of these tools? And then thinking through some more of those applications, but also looking a bit more towards the future and innovations on the horizon in this space. Where do we go from here? Okay? And in between these two, in addition to lunch, don't worry, we'll also have the lightning talk competition presentations and awards, where the 24 or so folks who submitted lightning talks, early career researchers, will the finalists will be up on stage here for you all to enjoy as well.